let's consider the chi-square test where the proportions are not the same. So our example here are the three colors of Reese's Pieces distributed as follows: 50% orange, 25% yellow, and 25% brown. So we want to test the proportions for several categories at once. So we're going to conduct a hypothesis test where P1, proportion of orange, is 0.5, P2, the proportion of yellow, is 0.25, and the proportion 3, the proportion of browns, is also equal to 0.25. And so the alternative hypothesis would be simply that at least one of those proportions is different than is stated. So let's take a sample. And so our sample, we observed 135 were orange, 85 Reese's Pieces were yellow, and 80 were brown. So from our sample, we're now going to compute a statistic. And in order to compute a statistic, we need the expected counts. So if we have in the null hypothesis that the proportion of orange is 0.5, we would expect half of those sampled, or 150, to be orange. And P2, the proportion of yellows, is 0.25, so we'd expect 1/4 of those sampled, 75, to be yellow, and likewise for brown. So we have our observed counts and our expected counts. So to compute our chi-square statistic, we're going to take each observed value and find the difference between that and the expected value, square that difference, and then divide by the expected value. So for orange, we have 135 minus 150 squared divided by 150. For yellow, we have 85 minus 75 squared divided by 75. And then likewise for brown, 80 minus 75 squared divided by 75, to give us a chi-square value of 3.166 repeating. So in order to find our p-value, we would just find the probability of seeing a chi-square statistic as large or larger than 3.16666 repeating, and we find that that p-value is 0.2053. So using StatCrunch to determine this, I'll need some observed values and the expected counts. So I'll create two columns, one for the observed and one for the expected. So if we go back up and we look, the observed values were 135, 85, and 80. The expected counts were 150, 75, and 75. So in StatCrunch, I'll select Stat, come down to Goodness of Fit Test, choose chi-square, and here I need to put in the observed values, and then the expected values were in the expected values column, and I'll put in, display the expected, and I'll even highlight some of these other values here just to kind of show you what they are. Press compute, and so here I have the expected values that I entered, but I also have residuals, how far away each was, and whether it was less than or greater than what was expected. And then the standardized values. If I were to square each of these values and then add the squared values together, that gives me my chi-square statistic. But here we see it gives us the chi-square statistic, 3.1666 repeating, and it gives us the p-value, 0.2053. So if I'm conducting a goodness of fit test, and I have the observed values and the expected values, StatCrunch will do the calculations and find the p-value for me. So once I have the p-value, then I want to state my conclusion, and in this case, since the p-value is quite large, larger than 0.05, the test is not significant. We failed to reject the null hypothesis. There is insufficient evidence that the distribution is not as follows: orange 50%, yellow 25%, and brown 25%. So if we don't have evidence that it's different than this, I suppose we can assume that the data that we collected is consistent with this distribution.